Hello students, welcome to the concept thresholding in image processing. Coming to the definition of thresholding is a fundamental image processing technique used to separate objects called foreground from the background in an image. It works by converting a grayscale image into a binary image. Okay, what is thresholding? Is used to separate the foreground and background. We know in the foreground there exist objects, so this thresholding is used to separate the objects from background. Image will be converted into binary from its grayscale form when you apply thresholding to an image. Okay, I'll show you the examples. See the example, brain phantom. So this is the original image and this is the thresholded image. And see this galaxy. This is the original image and this is a thresholded image. If you see this image, this is a color image. When you apply thresholding on this color image, first it gets converted into grayscale and then thresholded image. How to do this thresholding? To extract the objects from the background, select a threshold T as a value, as a numerical value that separates objects from background. What is this T? It's a numerical value. It's an intensity value. Yes. Then at any point x comma y in the image, you know the image has different pixels and all the pixels are having intensity. Okay. Now at any point x comma y, okay, consider a pixel at which f of x comma y is greater than t. What is f of x comma y? Intensity. And you have already chosen a threshold T. Okay. So now the pixel intensity, that is f of x comma y, is greater than this threshold. Threshold is also intensity value. Then that point, that pixel is considered as object point. Means if the pixel intensity is greater than the threshold, it will be considered as object point. Otherwise, the point is called a background point. This is the equation. What is g of x comma y? A thresholded image. So now the g of x comma y is defined as, it is 1 if f of x comma y is greater than t, hence it is object point. Yes, it is 0 if f of x comma y is less than or equal to t. Okay, means if you take a matrix image, if you take an image in the form of matrix with different intensities, then choose a threshold t, then compare every pixel intensity with t. If the pixel intensity is greater than t, mark 1, and if the pixel intensity is less than t, mark 0. Then if you observe the image is simply in terms of zeros and ones, which is nothing but binary image. If you consider a image like this, a grayscale image like this, if you apply the thresholding here, see this, there is black, there is gray, light gray, like that. Now choose a threshold, then apply the threshold concept, then automatically going to get the binary image. This is called single level thresholding because we have chosen only one T to separate object and backgrounds. Okay. Now multi-level thresholding. Multiple thresholding classifies a point x comma y as belonging to the background if f of x comma y is less than or equal to t1. Lowest intensities or backgrounds, remember. To one object class if t1 less than f of x comma y less than or equal to t2. Means if the pixel intensity is between t1 and t2, consider it as an object to one class. And the other object class if f of x comma y is greater than t2. Okay. Hence the threshold image g of x comma y is defined as, see this equation. If it is greater than t2, consider it as the object belongs to the class A. If it is between t1 and t2, consider it as the object belongs to class B. If it is less than t1, consider it as the background. There are two thresholds, t1, t2. That is the reason it is called multi-level thresholding. See, I'll explain these two concepts, single level thresholding and multi-level thresholding, using the histogram. See the histograms. For the first histogram, it is a histogram of the image with a dark background and a light object. You know the histogram. Histogram x-axis is intensity and y-axis is the number of pixels having that intensity. Okay. See here, this is all intensity. This x-axis is intensity And see, this bunch of the histogram points, bunch of the histogram impulses as nearer to 0 means it consists of dark background. And see this, that is nearer to the L minus 1, it consists of a small lengthed histogram samples, means it consists of light object. Okay, yes, image with dark background and a light object. Now if you want to separate this background and foreground, means background and object, you have to choose a threshold T between these two histograms. See here, there exists a valley point in which there is no histogram impulse. You have to choose the point midway between these two valleys, T. Now, less than T, this becomes 0, and greater than T1 means you are separating the background and foreground. Okay, so this is called single level thresholding. Now coming to this histogram, there exists dark background and two light objects. These samples represents the background nearer to 0, and you have two light objects because these are very nearer to the L minus 1. So with the single thresholding, you can't separate these two objects. So what you have to do, you have to go for multi-level thresholding. So below T1, consider it as background, and between T1 and T2, consider it as object for one class, and above T2, consider it as object of another class. I'll give you another example for thresholding, how to choose a proper threshold value. This is the original image and this is the thresholded image. You have to choose the threshold in a proper way, otherwise see this thresholded image is a good image, perfect image, no problem. But for the wrong threshold value, see the results. Threshold too low and threshold too high. Okay, so you have to choose the threshold in a proper way. Proper value of threshold is needed to get proper threshold output. This is the example for single level thresholding. See this, there are only two things, zeros and ones, cameraman image. So that is the reason it is single level thresholding. And this is the multi-level thresholding. Multi-level means you're going to have three classes. One is the foreground, another one is one object class, another one is another object class. So here are white, gray, this is gray and this is black. Okay. What are the types of thresholding? The two types of thresholding are basic global thresholding and basic adaptive thresholding. In the basic global thresholding, one single threshold value is used for the whole image, hence it is called global. Every pixel is compared with the same global threshold value. It works well if the lighting is uniform in the image. Coming to the basic adaptive thresholding, the threshold changes from place to place in the image. It is not constant. The threshold is not constant from the place to place. In the image, place means a neighborhood. If you change the neighborhood, automatically the threshold will be changed. Each small region of the image has its own threshold value. That is the same I said. Small region means the neighborhood. Since the threshold for each pixel depends on its location, with an image, this technique is said to be adaptive. Adaptive means it must be changing with respect to the region. With respect to the conditions, we must adapt to that situation. Okay, so that is the reason as the threshold is changing with respect to the considered small region or neighborhood, this threshold is called adaptive. It works better when different parts of the image have different brightness. It works even if the image is having different brightness at different places. So this is a simple difference between basic global thresholding and basic adaptive thresholding. Now we'll move in detail to the basic global thresholding. Whatever may be the type of thresholding, the thresholding is based on histogram. Okay, then only we can do the thresholding in a perfect way. Okay, partition the image histogram using a single global threshold, that is called global thresholding. The success of this technique is very strongly depend on how well the histogram can be partitioned. Okay, see this example, how well the histogram can be partitioned. Then means how well you are going to choose the threshold. You have chosen a good threshold means, yes, you separated the histogram, you partition the histogram in an effective way, means you separated the object and background. Okay, now, yes, if you see this example, figure A shows a simple image. Histogram of this image, figure C, shows the segmented result after applying a thresholded value. If you see the figure A, original image, it has many shadows. Yes, some blurring. This is the threshold. This is the histogram. Fine. Yes, if you observe the histogram, the background is white and the foreground is black. Okay. Large area is the background. So that is the reason, see the histogram, which is nearer to the 255. Because the background is white and that too the small that too the large background, that is the reason histogram is high. Large region means more number of pixels are having that white intensity. Okay, so that is the reason histogram is like this, and the foreground is less and it is black, so that is the reason histogram is very small here. Line is used to separate the histogram or partition the histogram. Then what happened? Yes, all the white. Here in the original image there are things like background, foreground and shadows and blurring like this, but in the thresholded image you are seeing only two things, background and foreground. Okay, so this works very well in controlled environments such as industrial inspection, where lighting and image conditions are stable and predictable. To do this basic global thresholding, we have an algorithm. See the algorithm. First, select an initial estimate for T. Typically the average gray level in the image. I'll explain this with an example, no problem. Choose an image and find the intensities of all the pixels and get the average of the intensity, that is called the initial estimate threshold T. Then now segment the image using the threshold T to produce two groups of pixels. G1 is one group in which there are pixels whose intensity values are greater than T, and G2 consisting of pixels with gray levels less than or equal to T. So you, after getting G1 and G2, you have to go for the average of the pixel consisting of G1, consider it as mu1, and average gray levels of the pixels in G2, consider it as mu2. Then compute a new threshold value T, that is equal to mu1 plus mu2 by 2. Repeat steps 2 to 4 until the difference in T in successive iterations is less than a predefined limit delta T. You have to consider a limit delta T. You have to choose a limit delta T. If the difference between this thresholds in these iterations is less than this delta T, then stop this process. Okay, now take the last threshold as a final threshold and do the segmentation. If both objects and background are roughly equal, then use average gray level as initial threshold. If one region is much larger, like this, the background is very larger than foreground, then at that time use midpoint between max and min gray levels as initial threshold. Delta T helps to decide when to stop thresholding process when changes are very small. This delta T is important for fast processing. Now I'll explain this algorithm by taking an example. See, this is the image. This is the 4x4 input image. Compute the initial threshold T0. How to find the threshold? Is you have to get the average of all these pixel intensities. So the average becomes 101.5625. Sum all those intensities divided by 16, you will get 101.5625. Now grouping has to be done. Grouping the pixels based on T0 is equal to 101.5625. G1. What is G1? Pixels of intensity greater than 101.56. So in all these pixels, so you have to group whose intensities are greater than 101.56. So all these pixels are having greater than 101.56. And how many? 1, 2, 3, 4, 5, 6. So compute the mean mu1 as sum of these intensities divided by 6. So it is 140. Then what is G2? Less than or equal to 101.56 threshold intensity. What is G2? G2 means the pixels consisting of the intensities less than or equal to 101.56. So in this 20, 45, 50, 70, 70, 75, 80, 85, 90, 100. If this are the pixels belongs to G2. Okay, then again compute mu2. 10 pixels are there in G2. Compute, get 68.5. Then find the new threshold T1, that is 104.25. That is mu1 plus mu2 by 2. Then take the difference delta T. What is delta T? Yes, this is the new threshold T1. The previous threshold is T0. So T1 minus T0 is 2.69. Yes, we have chosen delta T. Initially, we have chosen delta T as 1. As this 2.69 is greater than 1, hence again you have to start the process. Now take this T1 104.25 as the threshold. Again group the pixels, group this image pixels. Yes, these are the pixels in group 1 and these are the pixels in group 2. Again find mu1 and mu2, then go for T2. Remember, this step is based on the threshold 104.25 and this is based on the threshold 101.56. Okay. Then here find another threshold T2, that is mu1 plus mu2 by 2, which is nothing but 104.5. Then again find the difference, it becomes 0. Then yes, means the difference is 0, it is less than 1, means there exists convergence, hence take the final threshold as 104.25. Yes, why you have chosen? Because at this threshold value the difference becomes 0, so this becomes the final threshold. Now segment the image using this threshold. Okay, so this is about the basic global thresholding. This is the example: noisy fingerprint, histogram, segmented result using a global threshold. Yes, chosen delta T as 0, difference as 0. Yes, algorithm results the final 102.54 as threshold after 3 iterations. Okay, so let T equal to 125. So if you observe, this is the output of the global threshold. Okay, so what is the problems with this global thresholding? Global thresholding means single value thresholding. So what are the problems? Single value thresholding only works for bimodal histograms. Bimodal histograms means consisting of only 2 modes. This is one part and this is one part. These are called bimodal histograms. Images with other kinds of histograms need more than a single threshold. Like this needs more than a single threshold. So now take this example. Let's say we want to isolate the contents of the bottles. This is the bottle image. These are all the bottles. In the bottles, this is the liquid. Okay. And for this bottle, it is not totally filled. It is partially filled. So the concept is we want to isolate the contents of the bottle. About the histogram for this image would look like. What would happen if you used a single threshold value? If you see this image, it has 3 levels totally. Approximately you can take it as 3 levels. The background black, and bottles which are not filled or seems to be white, and if the bottle is filled with liquid, seems to be grey. But if you choose only single threshold, then you're going to miss one class. Okay, so this is the output. See this. See this what the content of the bottle is also considered as black if you go for single thresholding. So the problem is by the illumination. So this is the good illumination object and this is the histogram. Yes, you can do the single level histogram or global thresholding by taking the midpoint of these two max and min gray levels. Okay, so this is the threshold output. But for the same image, if the illumination is not uniform, see here the illumination is good, but here the illumination is somewhat less. So for this image, this is the histogram. Then suppose like this, if you choose the threshold value like this, if you choose the threshold value here also, then what will happen? Yes, even this becomes, yes, if you choose threshold, this part becomes white, though it is not white because it is less illuminated with high light. Okay, seems to be white, and this is dark. That is the reason it becomes dark. Actually, what must be the output? This must be the perfect output, but here because of this illumination, this bright illumination also considered as white if you go for single level thresholding. So this is the problem with single level thresholding. To avoid all these limitations, we are going for basic adaptive thresholding. This is an approach to handling situations in which single value thresholding will not work, and it is to divide an image into sub-images and threshold these individually. Yes, basic adaptive thresholding is used where single value thresholding is not giving good results. So what you're going to do in basic adaptive thresholding, you have to divide an image into sub-images and then threshold these individually. See the image here. Here the image is divided into parts, square parts, small square parts. Each image, each part is segmented individually. Each part is thresholded individually. For each part, you have to draw the histogram and you have to choose a threshold, and then you have to apply the threshold. Okay, so that is, as each part is having different thresholds, when you split the image into sub-images, this is called adaptive. Since the threshold for each pixel depends on its location with an image, this technique is said to be adaptive. Previously I have shown this is the image. With a single level thresholding, we are not able to get this image, okay, because of uneven illumination. But if you split this image using adaptive algorithm, adaptive thresholding, yes, we splitted the image, and for the each split, each sub-image, apply the thresholding process individually. That is the reason it is called adaptive. And then for each region, apply the threshold, you'll get the result, then merge all those results. This is the image. So compared to this, it is very nice. Yes, it is very much nearer to the exact output, this exact output. The problem here is only this part. Okay, so as can be seen, accuracy is okay. So to get more accuracy, then what you have to do? Again, you have to choose these. Yes, we have problem only for these two blocks, this block and this block. Am I correct? Again, choose these two. Again, choose these two. Again, split these two. Again, split like this. Again, split like this. Again, apply adaptive for these small portions. For all these blocks or for all these sub-images, the output is nice and accurate. Only for these blocks, the output is not correct. That is the reason, again, you divide those two, and again you go for thresholding individually. Then after 2-3 iterations, you're going to get the exact output. Okay, so this is about basic adaptive thresholding. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.